Welcome to today's webcast presentation, A Closer Look, Advanced Engineering for Fabric Buildings. My name is Bob Drake, editor of Civil and Structural Engineer magazine published by Zweig Group. Thank you for joining this webcast, which is sponsored by Legacy Building Solutions. Before we begin today's presentation, first some general information about the webcast. The views of the speakers and organizations participating in this webcast are their own and do not necessarily reflect those of Civil and Structural Engineer or its publisher, Zweig Group. If you have any technical difficulties while viewing this webcast, please submit questions or a brief explanation of your technical problem using the Questions tab on the right side of the webcast dashboard, and a representative will assist you. During the webcast, you also can submit questions to our speakers using the same Questions tab. Submit your questions at any time. We will try to answer as many as we can later in the webcast. Zweig Group encourages group learning for our events. If you are viewing the live webcast with a group on one registered person's computer, that person must complete and submit the multiple viewer registration form for the group in order for everyone to earn credit. Download the multiple viewer registration form from the Handouts tab on the right side of the webcast dashboard. Submission instructions are on the form. A certificate of completion will be provided later in the webcast. Viewers of archived webcasts note that they must pass a quiz in order to download a certificate of completion. Presenting today are Nathan Stobbe, Eric Dene, and Dwayne Munch. Nathan is General Manager of Legacy Building Solutions. He has over 15 years of experience in the fabric structure industry and has made significant contributions, including as a member of the original committee for developing CSA S367, the guideline for pre-engineered membrane structures, and is co-founder of the Membrane Structures Manufacturers Association. He also holds several patents for fabric structure construction. As General Manager, Nathan leads Legacy's growth through innovation and vision. Eric is Legacy's Vice President of Sales. He has over a decade of experience in customer service and sales, plus over 13 years of commercial construction experience. In his role at Legacy, Eric manages sales staff and processes and works to find creative solutions to customer requirements. Dwayne is the Senior Structural Engineer for Legacy Building Solutions. Licensed in 28 states and 5 provinces, Dwayne oversees the engineering department, where he is vested with the responsibility of providing engineering analysis, technical expertise, detailing, customization, and retrofitting of fabric membrane structures.
Today we'll be talking about the construction of fabric buildings. There are a variety of fabric buildings on the market today, ranging from simple tents that can be put up in an afternoon to fully engineered buildings on a rigid steel frame. This webinar will focus on rigid steel frame fabric buildings. During today's webinar, you will learn engineering considerations that must be calculated for a successful project, similarities and differences between pre-engineered metal and fabric buildings, fabric building construction safety considerations, and new information about energy efficiency in fabric buildings. These structures are permanent and semi-permanent buildings that are constructed on a foundation by trained installers. Rigid frame construction increases the structure's durability by enhancing how the frame carries environmental loads and applied loads. There are several benefits of rigid frame construction, including the ability to construct wide, clear span areas. The engineering of these buildings complies with building codes and is based upon universally engineered engineering standards for an increased ability to withstand snow and seismic loads and cost-effective and energy-efficient construction. As the webinar continues, you may notice that these buildings are structurally similar to pre-engineered metal buildings. Both use the same frame type and are fabricated at a manufacturing facility before being field assembled at the job site. The prevailing difference, however, is in how the cladding material integrates with the frame. In a metal building, steel sheets are screwed to light gauge subframing that is attached to the building frame, creating an exoskeleton that structurally aids the frames. In a fabric structure, the frame is attached to the frame via a heater rail. The fabric is not calculated as an exoskeleton for the structure. This support is added to the structure using secondary framing members and cables or cross rods attached to the frame itself. When we say engineering considerations are the same, we mean it. Fabric buildings should be held to the same engineering standards as metal buildings. You won't want to take unwarranted shortcuts with the important asset like a building, or risk the health and safety of the people in and around the building. Help your clients get long-term value from their building by upholding engineering and quality standards before, during, and after construction. Most engineers and experienced builders are familiar with the capabilities of pre-engineered buildings from the past experience. According to Metal Building Manufacturers Association, pre-engineered metal buildings comprise nearly half of all 1- and 2-story non-residential buildings in the United States. However, a lot of knowledgeable builders still don't have that experience and familiarity with tension fabric.
Hey everyone, I'm back. It's Nathan. We had some audio problems. Fabric buildings are known as tension membrane buildings. And like the cladding of steel buildings, the fabric provides an exterior shell to keep the exterior elements out. Using Legacy's patented fabric attachment system, the fabric is attached to the steel frame with a Keter rail and stretched to the proper tension. Unlike a metal building with thousands of screw holes and simple overlap panels, the fabric provides a superior building envelope, preventing air leakage from inside and moisture penetration from outside. We'll talk a little later about what the tight building envelope means in terms of energy efficiency. Another common question is how the strength of the fabric compares to the strength of other metal buildings such as steel. Coated PVC fabric like Legacy's exclusive Exotech provides 7 layers. The strength of the material comes from the base layer called the scrim. Both sides of the scrim are protected by a primer, a protective coating, and a top coat lacquer. The primer layer is designed to inhibit bacteria, mold, and UV rays, as well as enhance the chemical bond of the coating. The top coat prevents UV rays from penetrating the inner layers while providing a waterproof barrier and protection to the scrim. The final layer of the fabric is a lacquer. The clear lacquer has 2 primary roles: to keep plasticizers within the PVC from coming out, and to provide a smooth, self-cleaning finish. Many PVC fabrics are also flame retardant in accordance to NFPA 701 and the California Fire Marshals. The picture shows Exotech, which is a PVC fabric exclusive to Legacy. To demonstrate the strength of the fabric, Legacy placed a skid steer loader with a snow bucket on a sample of our Exotech Elite fabric. That's the CEO of our company driving the loader. And as you can see, the fabric combined with the attachment system supported the full weight of the skid steer loader, which was over 10,000 pounds. The next day, the fabric showed no signs of damage. Besides being a little bit dirty, if we tried to do this with a steel panel, we would have had a significant skid steer repair bill. Of course, in addition to gimmicky demonstrations that help us understand the strength of the fabric, we also have a proven track record when working with the real-life elements and pressures that buildings face every day. Dwayne will discuss some of those now.
Here we are. Thanks, Nathan. In many parts of the world, snow places significant pressure on the building roof. Any reputable building manufacturer will calculate the roof snow load. The building's ability to withstand snow depends on the shape and angle of the roof, the building's exposure, thermal factors, obstructions on the roof such as vents, and of course the roof cladding. Fabric has a smooth surface which makes the snow slide off it more quickly. In snow locations, Legacy buildings have at least a 2 to 12 roof slope which helps the snow slide off. Some fabric building manufacturers incorporate reductions in roof snow load based on the snow slide characteristics of snow on fabric. However, applying the full snow load requirement as stated in the building code ensures that the building is fully compliant and it provides a high level of safety to the building design. So how does the fabric hold up to heavy snow? This particular building is in the Andes Mountains of Chile and carries a design snow load of 246 pounds per square foot. You can see the secondary bracing, which gives the building additional strength to accommodate the snow load plus wind speeds of 75 miles per hour. In addition to snow and wind loads, the building is also designed to handle significant seismic loads as is required in Chile. It's designed for housing and maintaining a large mining equipment, so providing a protected area for workers is a primary concern for this facility. Wind exposure is dictated by the surface obstructions around the building. For example, buildings in densely built or wooded areas will have a different wind exposure factor than buildings not protected by other buildings or trees. Ensuring that the proper wind exposure category is used for the site location of the building is an important part of the design engineering for a building. Hurricanes are one of the strongest demonstrations of wind power. You've all seen the footage from hurricane damage. There's no way to guarantee that a building will withstand the force of the next Category 5 hurricane, but you do have the option to invest in building materials that have demonstrated the ability to perform in extraordinarily tough conditions. As a public safety measure, Florida has instituted rigorous testing that mimics hurricane conditions. Products that pass this testing are granted Florida product approval. What does this mean when choosing a fabric building? Make sure you ask if potential construction and building companies have Florida product approval to ensure that your building has passed this rigorous testing. The legacy building fabric and attachment system have been fully tested and carry Florida product approval. But of course, not all winds are hurricanes. Mountains and other open areas are also known for exposure to strong winds, and the wind exposure should be calculated as part of the building design. This building is along the Arkansas River and is engineered for wind speeds of 105 miles per hour. The building owner has a long relationship with Legacy. We recently contracted for the 5th building on site. Another notable feature is that this facility is off-grid with natural daylight that permeates the fabric, providing a naturally bright lit interior. Seismic ratings are defined by the occupancy rating of the building as well as the expected level of building movement during seismic events. Tension fabric buildings are a great option for areas and applications with seismic concerns. The flexible nature of the fabric allows for some movement of the frames without damaging the cladding. The fabric panels are permanently welded together, so there's no risk of fasteners coming out of place or causing damage to the fabric. Even with the advantages of fabric during seismic events, Legacy does not use the fabric as a lateral brace, but it is an additional safety feature that isn't calculated in the building design. This is a 60 by 60 manufacturing building with a seismic design category of C. It uses a concrete slab foundation to account for the soil conditions. The sidewalls are 22 feet in height to create more space for equipment and manufacturing inside. You can see in the background that this building is connected to a steel building that was already in place. We'll talk a little more about how tension membrane buildings connect to other building types later. The building's use will determine collateral loads, which consist of anything added to the building frame. This includes systems like lighting, heating, and cooling, conveyors and catwalks, overhead cranes, fire suppression systems. These loads are in addition to the required environmental loads, and the building designer will need to account for the total of all live and dead loads. Supporting collateral loads is one area where rigid frame fabric buildings have a clear advantage over buildings using open web trusses. Trusses are fabricated in standard sizes, leaving customers to choose between an under-engineered truss or a more expensive over-engineered truss. Because trusses are more prone to movement under environmental loading such as wind or snow than rigid frame designs, this often leads to increased maintenance and downtime on systems with moving parts such as conveyors or overhead cranes as compared to similar systems hung from the rigid frame system. Some collateral loads are not distributed evenly among the building frames. For example, stairs and jumbotrons, conveyors, cranes, or other hanging loads. Trusses typically can be designed to accommodate these point loads only where the web meets the cord. With rigid steel beams, these loads can be placed anywhere in the building or along the beam for truly custom placement. This structure for Smithfield Foods features several hanging loads. The overhead conveyor and filling equipment leave plenty of clear span storage space, a must for this bulk feed distributor. A staircase suspended from the building frame allows maintenance staff access to the conveyor as needed. Also visible in this picture is the liner, which prevents dust from settling on the frame, and the 10 to 12 roof pitch, which maximizes the available footprint by allowing for taller feed piles. The type and quality of the soil beneath the building will have a significant impact on the foundation. Soils high in peat or clay may not have the strength to support a fully loaded building. Changing the soil type is prohibitively expensive. The entity designing the building foundation should complete soil testing. An experienced building engineer will design a building foundation that will support the weight of the building on your site. Fabric buildings are comparable to pre-engineered metal buildings, and they have nearly identical foundation requirements. If a fabric building manufacturer is claiming that a permanent or semi-permanent building code or building does not require a foundation, ask them to back that up with accepted engineering calculations. Occupancy rating is determined by the building's use. A structure that is designed for regular use by people will have a higher occupancy rating than a storage building. One caveat to remember related to occupancy rating: it's much easier to get event permits in a building that is rated for higher occupancy. If you plan on holding public events, please make the investment in a higher occupancy building before construction begins. Retrofitting an existing building for a higher occupancy rating can be expensive and time-consuming. Sports centers are often designed with a higher occupancy rating. This allows the building owner to use the building for a wide variety of activities, including camps, tournaments, or even recognition banquets. A great example is the Oklahoma City Tennis Center. Part of the local Parks and Rec Department, it's the largest public parks facility in the central United States and includes 6 indoor tennis courts. Everything was designed to meet USTA standards. The building is insulated for year-round use, and the white liner reflects the LED lighting to magnify the lighting available at each court. This building has a quiet climate control system for tennis events and tournaments. This tennis center, was named Municipal Facility of the Year by Tennis Industry Magazine, as well as USTA Outstanding Large Facility. Of course, there are things you may want to add to your building as well, features and design options that will add value and character based on your specific use. Since rigid frame fabric buildings have similar engineering to pre-engineered metal buildings, they have the same design options. With a rigid frame fabric building, any size and shape of building is possible. While most buildings follow the standard gable shape, that's not a requirement. Barrel top buildings, monoslopes, lean-tos, off-center peaks are available to give your building increased functionality or a unique look. And now Eric will share some of the other options for building design.
Thanks, Dwayne. Overhangs are another benefit of the traditional gable-shaped of rigid frame building design. In addition to giving the structure a traditional look, especially important when the building will be part of a larger campus, overhangs also provide the basis of a passive ventilation system. Overhangs with mesh soffit allow fresh air to enter close to the occupied level of the building. This air will naturally rise as it heats up and becomes saturated, exhausting out peak vents. In many cases, a passive ventilation system will provide all the necessary required circulation. Gutters and downspouts may be added to the overhangs to divert the flow of water and provide a dry area around the building. In many situations, a water management system is required to provide a safe walkway, meet airport regulations, or to protect landscaping or other surrounding features. We mentioned earlier that tension fabric is designed to help snow slide off the roof. Many legacy buildings' designs also include icebreakers, which break the sheets of snow and ice into more manageable chunks before they strike the ground. With the straight wall design and custom engineering, doors, windows, and openings can be placed anywhere along the end walls or side walls of a rigid frame building. Jack beams allow for extra wide openings at the sidewalls. The strength of the frame and the needed header space may be adjusted to accommodate any number of size of doors, including mega doors, bifold doors, bottom rolling doors, multiple overhead doors, or other openings. Door placement is another consideration during the building design process. Doors on opposite ends of the building create a simple circulation path for heavy equipment. Personnel doors may need to be located at strategic locations throughout the building to properly account for life safety issues as required by building code. It is possible to add doors once construction is complete, but it's easier and less expensive to install them correctly the first time. Roof-mounted solar panels are installed parallel to the roof beams for maximum sun exposure. The extra load of the panels and racking will be accounted for in the building design. Occupied buildings will require insulation for year-round use. Batten insulation up to R30 is available in the walls and roof of the structure. In insulated buildings, an interior liner will protect the insulation and provide a smooth, bright finish to the building's interior. Insulated fabric buildings have two big advantages over similar metal buildings. The first is that the fabric liner makes a tight vapor barrier for the building, reducing heating and cooling costs through reduced air leakage. This is a result of a continuous membrane liner instead of the fabric vapor barrier, which is dependent on tape joints to maintain continuity as a typical metal building. The liner also provides a clean finish inside the building, effectively hiding all exposed framework. This can lead to better acoustics within the building as sound are not bounced off multiple surfaces. This has proven to be beneficial in sports centers and entertainment venues. Uninsulated buildings may also be lined for corrosion protection. Structural fabric, including Legacy's exclusive Exotech PVC fabric, is non-corrosive. Adding a fabric liner to the underside of the frame keeps the steel frame out of contact with all corrosive elements, including salt, fertilizer, and moisture. This is a cost-effective alternative to epoxy paints that are often used to stop corrosion, and a permanent alternative that is not subject to pitting or thinning when exposed to corrosive elements. Depending on the use of your building, there are specific engineering or quality requirements that may want to ask about. Although these considerations are optional, they are a good indicator that your manufacturer is thoughtful and experienced with your building type, and that they are knowledgeable about the features you need. When storing bulk material, the primary consideration is the amount of space available and if it will hold your product. A too small building will cause problems from day one, and a too large building will incur extra expenses that can eat away at your profits. The solution is pile size modeling. Using computer-generated pile drawings such as these by Legacy will show the square footage needed to store your tonnage. Then a building will be drawn around the pile drawings, including the necessary height for stem walls and the building itself. This building is an example of pile drawings assisted in building design. The customer needed to store 6 different products in separate bins. The Legacy team created models to show the size of each individual pile. This model demonstrated how the product will fit in the available footprint and determined the height of the concrete barriers used to create storage bins. The building storage cavity was designed around the piles. After the storage area was designed, the team added lean-tos to create space for loading, operations, and equipment storage. When the structure will be used as an indoor sports center, it is vital to consider the dimensions required by that sports governing body, plus any extra space needed for pro shops, storage, locker rooms, or offices. This is another instance where considering all potential building use before construction begins will give you great flexibility in the long term. These buildings are often used for hangars or truck shops. The building designer should be able to create a rendering showing the exact dimensions of your vehicle and how it will fit into the building. Using these scale drawings will give project stakeholders the chance to consider how anything else in the building will interact with the vehicle. For example, you will need another door for personnel to enter safely, and where will it be placed? Will there be room for a bridge crane on a tipping truck or moving around in the building? These considerations will help avoid disaster. There are some building considerations that apply to buildings in all industries. For more on that, here's Nathan.
Thanks, Eric. Interior finish is another major difference between pre-engineered metal buildings and fabric buildings. In an engineered metal building, the frames, insulation, and secondary bracing are visible inside the building. While this may be okay for industrial use, a brighter fabric liner will provide a superior interior look. The fabric provides a smooth, uninterrupted surface, a gleaming white surface that will reflect lights and magnify the brightness inside your structure, without contributing to glare or creating dark spots or shadowy corners. The building owner can even point light fixtures upwards and rely on the reflection to create brightness inside the building, creating a distraction-free interior that is especially useful in sports centers, concert venues, and even riding arenas. This is also useful in applications that require a clean environment with no spots for dirt or bacteria to collect. The liner provides a smooth, easy to clean sealing surface. Before construction begins, it's important to do your homework and vet your supplier. Talk with previous customers, tour other buildings, do what's necessary to get a feel for the responsiveness of the company. Other quality indicators like ISO certification, AWS and CWB certifications, and Florida product approval also indicate your builder takes the necessary steps to provide a quality product. After the building plans are drawn and approved and contracts are completed, building component manufacturing can begin. Building strength, longevity, and quality are directly related to the engineering and materials used in construction. Rigid frame construction using solid I-beams is one of the most tested and trusted framing systems available today. The solid steel frames have an increased ability to carry vertical loads. Using a rigid steel frame allows the ultimate in design flexibility. A custom design optimizes the building for long-term use by meeting all performance criteria, mitigating the overall project design costs, and providing value during construction by minimizing the time spent on building and managing the project. Rigid frame buildings are designed three-dimensionally, giving you space inside your building for your application. There is no wasted square footage. The building is optimized to provide maximum space for material, equipment, and personnel. Fabric panel manufacturing is the process of taking fabric from the manufacturer's roll, cutting it, and preparing it for the attachment to the frame. Before any of that begins, the fabric must be quality tested. These tests consist of visual inspection, looking for color variances, as well as mechanical testing that measures the fabric strength. Once the fabric has passed all quality inspections, panel manufacturing can begin. Panels must be tested to tight tolerances that account for the precise amount of stretch present in any given fabric. Precision manufacturing is especially important to incorporate the required amounts of pretension when using individual fabric panels, as the size of the fabric is what provides the biaxial tension on the panel and prevents excessive movement and premature wear. Once panels are cut and aligned, individual pieces of fabric are welded together using hot air, wedge, or RF welding systems. The strength of the fabric weld should be the same as the strength of the fabric itself. Once the fabric panels are manufactured, they can be rolled and packed for shipping to the building location. Another thing to be aware of is the construction process. Safety should always be a primary concern on the job site. Speed and conformance to building plans are important factors as well, but it's impossible to achieve those goals if people are getting hurt on site. Not to mention the paperwork costs and damage to your reputation that comes from job site injuries. Construction safety is another factor that separates fabric building manufacturers. Many installers working in open web trusses install the frames and then flex them one at a time during installation, leaving secondary members unattached during the installation process. If a strong gust of wind blows through while the frame is flexed, it is likely to harm the building or anyone around it. Flexing the trusses brings up additional quality and safety concerns. When the trusses are bent and pulled and twisted into place, as you see on the bottom picture, that compromises the integrity of the building. When the building supports can be manipulated that easy, it's not a good sign for the integrity of the building. Legacy's patented fabric attachment system ensures that the solid steel frames are not subject to flexing or bending during construction, and all secondary bracing is installed prior to installing the fabric panels. These designs help to ensure that safe install is of the highest priority. As we mentioned, speed of construction is an important factor in the installation. Finishing the building construction sooner means dollars saved on construction costs, plus dollars earned for faster occupancy and use of the building. Speed of install is one of the areas that fabric structures outrank steel. Large sheets of fabric are pulled and attached into place about 3 times faster than steel panels are installed. It's common in the industry to use contracted crews with minimal training to install the buildings. This might save a few dollars in the short term, but it causes a disconnect between the building's designers and installers. If everything goes exactly as planned during construction, it's a minor issue. But when special circumstances come up, they almost invariably do, it's best to have an in-house team that works together and communicates clearly with each other. If, for example, anchor bolts are not properly placed, a design team and construction team must work together to implement a solution. Siloing teams has no benefit to the end user. Often, building construction is not the only activity taking place on a site. Before engaging a construction team, ensure they understand and are prepared for site restrictions, whether that's equipment that must remain operating inside the building during construction or other projects taking place at the same time. An experienced builder will have a plan for working together with the other activities. Before construction begins, be upfront about what you need to accommodate and work together to create a plan. Unfortunately, there is no way to guarantee that your construction crew will have the experience and integrity you need before construction begins. But by asking specific questions of your builder and evaluating their credentials, you can have an idea of what type of company you're working with. Some clues that your construction crew is qualified and trustworthy include a company that has several years of experience, licensing and bonding for the project of your size, and adheres to the standard practices such as OSHA and ISO 9001:2015. Of course, after planning and construction are complete, the end user will be dealing with the building for a lifetime. During the completed building life cycle, long-term value and efficiency are important factors. Saving money on construction is great, but saving money over the life of the building will truly realize the value of the project. Fabric buildings are proven to save money on an ongoing energy cost basis. Fabric has two primary advantages when it comes to energy saving: natural light and energy efficiency. Energy efficiency is a little known but significant feature of fabric buildings. The continuous membrane of the fabric liner eliminates all air leaks as seen on steel buildings. First, the fabric tightly seals around any openings, prevents the leaks that commonly occur around vents and closed doors and windows, but perhaps, and most importantly, the fabric is attached to the frame without screws or nails, eliminating thousands of tiny holes that cause both air and water leaks in steel buildings. These fasteners are also common starting points for corrosion, which over time will cause even more holes and leaks. Finally, overlapping metal panels do very little to prevent air and weather-tight finish. The tight seals and lack of holes in the building envelope create a building that is less drafty than a comparable steel building. In fact, independent testing has shown that legacy buildings are 157% more efficient than a comparable steel building. An air infiltration test at this multi-sport building in Minnesota showed an impressively low 0.92 air changes per hour. Architectural fabric can have some degree of translucency. Exotech PVC that Legacy uses has up to 16% translucency. On a sunny day, this provides enough light to safely work inside the building. Natural light spreads through the building, preventing shadowy corners or dim areas that are common inside steel-cladded buildings. This natural light can also mean a significant reduction in the number of light fixtures that must be installed and maintained through the building. Insulated fabric buildings do not have the benefit of fabric or natural light inside, but the white liner does serve to reflect and magnify the brightness of the lighting system, creating a bright, glare-free interior. Here's a Minnesota sports building again. You can see the clean, polished look of the structure. It's a bright, clean-looking structure without drafts, the perfect environment for high school sports or whatever applications happens to be. Eric is here to talk more about the applications for fabric buildings.
Thanks, Nathan. The nature of fabric itself has advantages for many industries. For example, fabric structures are classified as Group 4 buildings by the National Fire Protection Administration. In applications such as aviation, NFPA 409 states that Group 4 buildings with less than 12,000 square feet of fire area do not require a sprinkler. Larger buildings require significantly less aggressive sprinkler systems, potentially saving thousands of dollars during initial construction and the lifespan of the building. This bottom ash dewatering facility in North Dakota measures 220 feet wide by 240 feet long and uses a hot-dipped galvanized steel frame. The combination of steel and fabric allow for the wide clear span area, which was specified to accommodate the equipment and settling pools, most of which were in place during the building's installation. The ventilation system in this building, including exhaust fans and ridge vents, are designed to produce 6 air changes per hour. Here is Soccer Blast, another sports facility. In this picture, you can see the gambrel roof shape, which creates more headroom for flying balls and equipment. Glazed windows along the end wall provide natural light inside the insulated building. You can again see the bright interior finish of the building, which makes it a more pleasant environment for year-round soccer play. LED lighting and a sprinkler system are suspended from the ceiling to comply with building regulations. You can see this building at its first location in Cerritos, California. This particular building is designed to be relocated multiple times as Lexus upgrades dealerships around the country. Because the fabric is installed without fasteners, it's easy to remove the fabric from the keter rail, roll it up, and install it in a new location. Even though you see it here in Southern California, it is compliant to a 35-pound snow load for future relocation. Window panels are installed along 3 walls to create a high-end appearance the dealership expects. Here's a fertilizer storage building in Woodbine, Iowa. Rather than the traditional lean-to design you saw earlier, it is essentially 5 buildings designed as one. This unique building is designed to store 6 fertilizer products in precast concrete bins with loader access to all bins. The middle building houses loading equipment and a drive path, so the entire operation from the product arrival to distribution takes place within one facility. 3 different beam sizes mean there are no obstructions within the building, just a safe and cost-effective way to store and handle 3,500 tons of product. And that concludes our webinar today. We have covered fabric buildings from the planning stage through design, construction, and use. Through case studies and examples, we've shared how these buildings have design flexibility and consideration nearly identical to all other pre-engineered buildings. And finally, you've seen how fabric itself has advantages for several applications. And now I'll turn it over to Bob for the Q&A. Our contact information is on the screen. We look forward to learning more about your project anytime.
Okay, thanks. Well, for the next few minutes, the speakers today will respond to some of the questions that have been submitted. So please continue to submit questions using the Questions tab on the right side of the webcast dashboard. So the first question is, what is the standard width between frames? And are there any options for different widths?
Well, at Legacy, our standard width between frames is 20 feet on center. We do many different options, and it really depends on the customer application. Sometimes we'll be a little bit narrower than that, and sometimes a little bit wider. With the fabric, we tend to like that 20-foot base spacing. It seems to be the spot where the fabric interacts perfectly together with the frame system.
So how long is your nominal custom design period?
So with regards to design, I'll let Dwayne answer this a little bit, but it really depends on how many different features are factored into the building. But on a basic building where we're not adding cranes or conveyors or anything like that, our design period is typically 2 to 3 weeks, which allows us to do all the engineering and provide the drawings that the customer needs for approvals.
Right, yeah. The complexity of the project will greatly affect that time. So it can come through engineering and drafting, but we usually like to get a set of preliminary reactions out to a client just to make sure they can start going ahead with their foundation system at the same time. But yeah, it will be greatly impacted by the different features you add to the building.
Okay, next question. Could a legacy frame be recovered at the end of the lifespan, assuming the frames are still acceptable? And is this cost effective?
Oh, absolutely. And this is one of the great benefits of the legacy structure. I mean, the frame is designed to last indefinitely, and our fabric attachment system, which is patented, really allows for a simplistic fabric replacement, and it's extremely cost effective as it relates to any other building, in terms of ongoing maintenance or repair. It is one of the reasons why people choose legacy on an ongoing basis.
A question here about insulation. What is the R value if you only use a liner without insulation?
That is a good question. It's probably up to interpretation a little bit, but a building with a liner and no insulation really technically has no R value, or it's R1 or 2, but it's not significant. That's why most insulated buildings that we're involved with, we use R30 insulation to provide a very good basis for heating the building.
I have a couple questions here dealing with the fabric. What is the lifespan of the fabric, and how to repair damage during its lifespan?
So lifespan of fabrics can vary quite a bit. The legacy Exotech PVC has a 25-year warranty, and basically the lifespan expected is in that 25 to 30 years. But there's other fabrics that are significantly less, and so ensuring that you have a quality fabric is one of the key important roles. There's players out there who will sell a cheaper building but cheap fabric, and the looming replacement of that fabric is a significant cost that has to be factored into that overall plan. And so our strategy has really been to focus on providing high quality fabrics for a long life.
Are there any environmental conditions that the fabric can't withstand presently?
Not that we've found. I mean, fabric is basically a non-conductive, non-corrosive product. Anytime that we're going into, and this happens particularly in mining applications where we're looking at a particular residue or dust that might come in contact with the fabric. We always work together with the manufacturers to ensure that it has no detrimental impact on the fabric, from a life standpoint. But by and large, it's a pretty inert product, which allows us to cover many different applications.
So are the interior liners the same as the exterior liners?
Yeah, typically the interior liner is the same type of fabric, but it's usually lighter in weight because it isn't carrying snow load or anything like that. So it's not as thick, but it's the same material. We use PVC fabric on the interior liner as well, and so it has the same characteristics. It just isn't as heavy, and because it doesn't have to carry snow load or wind load.
And what about color choices for the fabric?
Well, this is the great part about PVC fabric is we have 5 standard colors, but ultimately you can get the fabric any color in the color chart, and it really allows us a lot of flexibility. We've done projects where we've worked with the buildings and provided customized fabric which matches perfectly in line with a customer's colors that they would have in their logos or things like that.
So how well do fabric roofs and sprinklers operate together? And at what temperature will the fabric melt?
So fabric and sprinklers is a good question. One of the unique benefits of the fabric, and we didn't talk about this in this presentation, that however at high temperature, so in a fire situation, the fabric will actually melt back and allow the heat of the building. That temperature is significantly higher than the temperature required to set off a sprinkler head. And so your sprinkler head will always go off as the heat starts to build up. If you get a big flame going up, which causes melting of the fabric, the significant benefit really relates to allowing the heat to escape the building most building damage in fires is caused by heat buildup, which causes metal frames to buckle and bend and collapse. I did miss one of the questions actually earlier, which was how easy or difficult is the fabric to repair? And the answer is, one, it's difficult to damage because of its flexible nature, and so you can bump into it and generally you're not going to cause any damage to it. However, from a repair standpoint, you can weld a repair right onto that fabric, and so similar to metal, you can weld fabric and basically seal off an area that was damaged.
Okay, another question. We've looked at truss frame fabric buildings in the past. Why are rigid frame fabric buildings better than truss frame ones?
That is a really good question. I'm going to actually let Dwayne answer that question because he's very passionate about it.
Okay, yeah, well, I mean, the beauty of the rigid frame, of course, is that it has the solid web is just superior to the truss in its ability to withstand all kinds of different loads that the truss is not as forgiving. So so as far as wind and seismic and snow and all those other things, your rigid frame and adding low point loads to the frame, it's going to be much easier to be custom when you add those loads because you have a solid web. The truss is typically you're going to want to put point loads like at a cord web location because that's going to transfer it into the truss more easily. So you've got this whole panel point where everything has to be located, and that whole length between the panel points is kind of an area you can't really touch without doing some special design of the truss. Additionally, the difference between the frames is that there are so many connections of webs to cords that you have all kinds of problems with, deterioration of welds and were welds done properly on those from the web to the cord. So you just have a lot of issues that can happen. And typically trusses are much more sensitive to deflections than a rigid frame truss. So it's going to be a lot stiffer a rigid frame than it will be if you have a truss. And there's other things that are escaping me right now, but those are just the first three that I could think of.
Okay. We're going to go with one last question here. What applications are municipal government clients typically using fabric buildings for?
There's a pretty wide range on that. I mean, we go all the way from salt storage facilities to water treatment plants into athletic complexes. Many municipalities run athletic complexes or multi-sport sites for their community, and so we get involved in all sorts of projects like that. And I missed a few more things like fire halls. I mean, we've really been involved in practically every type of building related to a municipal government.
Okay, well, thanks. So as we finish up, please be sure to download your certificate of completion from the Downloads tab, enter your name in it, and print and save a copy of the PDF. Note that the certificate will be available only during the remainder of this webcast. A hard copy will not be mailed or emailed to you. If you missed our note at the beginning and you are watching the live webcast with a group on one person's computer, please download the multiple viewer registration form and complete and submit the form to receive credit. Answers to all of the questions submitted today will be available online within a few days at csengineermag.com/continuingeducation. So please check there for further discussion about today's topic. Additionally, this webcast has been recorded and will be archived on csengineermag.com/continuingeducation. For viewers of archived webcasts, click on the quiz button on the event on the CS Engineer Mag website to take a quiz on the presentation. Archive viewers must pass a quiz in order to download a certificate of completion. So thank you to Nathan, Eric, and Dwayne from Legacy Building Solutions, and to everyone who joined us. This ends today's webcast.